The battery in my digital pen seems to be going out, so I'm going to do the best I can here. This is on linear programming. With linear programming, you have a function, and that's called the objective function. And you're trying to find the maximum or minimum on this objective function. Now, you will have some constraints. Usually these problems come from some real-world problems, like you're trying to maximize a profit, but you have constraints. Say you have a limit as the number of hours that you can use, or something like that. And so let's say that we have the objective function is c equals x minus y. And in this example, we already have a graph given to us. And let's see, this is in tens. We have 10, 20, 30, 40. And 10, 20, 30, 40. And we have a polygon that defines our constraint function. So we have a point here at 0, 40. And we have a point here at 40, 0. And we have another point at 30, 30. And these points define the vertices of this polygon that would come from our constraints. This area inside here is called the feasible region. So in this particular example, the feasible region is already given. So to find the possible maximum or minimum of this, given our constraints, you take each vertex and you plug it in. So this is x and this is y. So for the point 0, 40, c equals x minus y, or c equals 0 minus 40, which is negative 40. For this point here, which is another vertex, 0, 0, c equals 0 minus 0, or 0. For this point, 30, 30, c equals 30 minus 30, or c equals 0. And for our last point, 40, 0, c equals 40 minus 0, or c equals 40. So our maximum is our biggest number, which is 40, which occurs at x, y equal to 40, 0. And our minimum is our smallest one, which was negative 40. And that occurs at the point x, y equals 0, 40. Okay, so that's how you do one when your constraints are already given to you in a diagram, and this is called your objective function. That's the thing that you're trying to maximize or minimize. Now let's see how we do it if you have one where they just give you the equations. Alright, so let's say that our objective function is c equals x plus 4y, and we're trying to find the maximum or minimum values of this function subject to the given constraints. And so the constraints that we're given are x is greater than or equal to 2, x is less than or equal to 5, y is greater than or equal to 1, and y is less than or equal to 6. So first we're going to graph these constraints. So x greater than or equal to 2. An x equals line is a vertical line. There we go. X is less than or equal to 5. So 3, 4, 5. So that's 5. That's 2. Y is greater than or equal to 1. So a y equals line is a horizontal line. That's 1. Y is less than or equal to 6. That'll be 6. Okay, so this was our axis here. And this was our axis. So now let's see what region we want. We want x greater than 2. Here's x equal to 2. X greater than 2 is on this side. We want x less than 5. Here's x equal to 5, so x less than 5 is on this side. We need y to be greater than 1, so that's above this one, and y to be less than 6, so that's below this one. So the region that matches all of these is this region here. Now we need to figure out the coordinates of our vertices. Okay, this vertex had x equal to 5 and y equal to 6, because this was the line x equals 5 and this was the line y equals 6. This vertex has the coordinates x is 2 and y is 6. This vertex has the coordinates x is 2 and y is 1. And this vertex has the coordinates x 5 and y 1. Now we evaluate our objective function at each of these vertices. So at 2, 6, c equals x plus 4y, or 2 plus 4 times 6, or 24 plus 2 is 26. At 5, 6, c equals x, which is 5, plus 4 times y, so y is 6, so 4 times 6 is 24, or 29. At 5, 1, c equals x is 5, y is 1, so plus 4, c equals 9. And at 2, 1, c equals 2 plus 4, or 6. So this is our smallest value, that's our minimum. That's our biggest value, that's our maximum. So we have our max equals 29 at x equals 5, y equals 6. Our min is 6 at x equals 2, y equals 1. Okay, now again, these will usually have some association with some real-world problem, usually having to do with profit. Now let's take a look at another one that's a little harder. Let's say that our objective function is c equals 4x plus 3y, and our constraints are x greater than or equal to 0, 2x plus 3y greater than or equal to 6, (3x plus 2y is less than or equal to 9), it should have been 3x minus 2y, and x plus 5y is less than or equal to 20. So let's check x greater than or equal to 0, 2x plus 3y greater than or equal to 6, 3x minus 2y less than or equal to 9, and x plus 5y is less than or equal to 20. Okay, so now we want to graph all of these. So these are all lines. That's why it's linear programming, because they're lines. So I'll draw my axes here. X greater than or equal to 0. Okay, so x greater than or equal to 0. Of course, that is y equal to 0. X greater than or equal to 0 is going to be this line, because an x equals line is a vertical line. So that's x greater than or equal to 0. 2x plus 3y is greater than or equal to 6. Well, given the equation in this form, it's probably easiest to graph it using the intercepts. So you can find the x-intercept by saying that y equals 0. When y equals 0, x equals 3, so that'll be the x-intercept. So when y equals 0, x equals 3, so that will be the x-intercept. To find the y-intercept, let x equal to 0. When x is equal to 0, y must be equal to 2. Okay, so this line then looks like this. Okay, so this is our first line, this is our second line. Now let's look at this one, and we'll figure it out. So to get the x-intercept, let y equal 0. So when y equals 0, x equals 3, so that's this point. To find the y-intercept, let x equal to 0. So when x equals to 0, y equals negative 9 halves. So negative 9 halves. 1, 2, 3, 4, 5. Negative 9 halves. This is 1, 2, 3, 4 and a half. So it's this line. Okay, this last one, to find the x-intercept, say y equals 0, then x equals 20, so that's way out here. To find the y-intercept, let x equal to 0, and that gets you y equals 4, so that's here. So here's this line. Okay, so now let's figure out what region we're talking about. X has to be greater than or equal to 0. Here's x equals 0, so we have to be completely on this side. This one was 2x plus 3y is greater than or equal to 6. So 2x plus 3y is greater than or equal to 6 is this line. Now to figure out if you need to shade above or below, pick any point in the region to check. Like this, a point up here would be 10, 10. Put the point 10, 10 in here and see if you get a true statement. And if you do, you know that that's the region you would have to shade in. So 10, 10 is here. 20 plus 30 is certainly greater than 6. So that's the region we'll shade in. We'll shade in above. If I thought maybe my region was here, I'd pick the point 0, 0. So 0, 0, when x is 0 and y is 0, this would give me 0 is greater than or equal to 6, which is a false statement. So I know that the region to shade in here is the region above this line. So now I have the region to the right of the red line, above the black line. Now for this one, 3x minus 2y is less than or equal to 9. Oh, let's see, which line was that? That had to be the one, let's see, so that was this one here. So that'd be this line right here. So let's check 0, 0. When I put 0, 0 in, 0 minus 0 is less than or equal to 9. So for this line, I'd shade the region above. So let's see, we've got the region above the green line, we've got the region above the black line, the region to the right of the red line. Now for this last one, x plus 5y is less than or equal to 20. That's this line. Let's pick the point 0, 0 again. 0 plus 0 is less than 20, so that means that's the region to shade in for this one. So the region that's in common for all of them is the part that's in between these lines right here. So we want this region that's in the middle here. This will be the region that we actually want. Now we need to find the equations of the vertices. So this one is easy. We know what that one is. We can just tell from our graph. That's 3, 0. This one is also easy. We can tell from our graph. That one was 2, 0. And those were our intercepts for this line anyway. Here's another easy one. That was the intercept for this bottom line, and that one, sorry, this one should have been 0, 2, and this one is going to be 0, 4. So the one that we have left to find is this one. Well, that point is the point of intersection of this line and this line. So we need to find the point of intersection of these two lines. So I'll set 3x minus 2y equals 9 and x plus 5y equals 20. I want to find the point of intersection of these. Well, I can do this using any method for solving a system of linear equations. One method is to multiply one equation by a number. That will make it so that when we add these two equations together, one of our variables will cancel out. If I multiply this bottom equation by negative 3, then a negative 3x plus a positive 3x would give me 0. So when I'll rewrite this first equation, 3x minus 2y equals 9, multiply the bottom equation through by negative 3, negative 3x minus 15y equals negative 60. I add my two equations together. I get negative 17y equals negative 51, and if I'm lucky, then y will equal 3, which it does. Okay, so I get y equal to 3. To find what x is, I plug this y equals 3 back into here. So 3x minus 2 times 3 equals 9, or 3x minus 6 equals 9, 3x equals 15, or x equals 5. So this gives me the point 5, 3. So now I have the coordinates of this vertex, 5, 3. Now to find the max and minimum of this function right here, I plug in the values for all of my vertices. So at 0, 4, so I think I'll make a little table here. So I've got x, y, and 4x plus 3y. So for my first point, 0, 4, I get 12. Okay, for my next point, 5, 3, I get 29. Then for 3, 0, I get 12 again. For 0, 2, I get 6. So this corresponds to my minimum, and this corresponds to my maximum. So my max is 29, and that happens when x equals 5 and y equals 3. My min is 6, and that happens at x equals 0 and y equals 2.